Yo guys, welcome back to my channel. So my friends are on in this today's episode and today's video, we are basically, we're going to deal with the so-called theory of vibrations. So guys, in order to basically deal with this so-called vibrational theory and aero-elasticity, guys, let us basically, try to break down that vibrational theory, guys, into two major domains. Guys, one is the vibrational approach, and second, guys, is the approach of the aero-elasticity. And guys, as the way in which that heading goes, guys, vibrational theory and aero-elasticity, guys, what it simply means is, guys, that is, basically a theory of vibrations, guys. For the purpose of studying mechanical vibrations and even torsional vibrations, and even, guys, in order to deal with the equations of the simple high harmonic motions, guys, we got to study the theory of vibrations. So, guys, basically, vibration, it happens to be of multiple types, guys. So there happen to be some great enlistments, guys, and when it comes about the types of vibrations, such as the longitudinal vibrations, even the torsional vibrations, even the transverse vibrations, even the deterministic vibrations, and so on. So, guys, there seems to be even the damped vibration, and even the undamped vibration, and even the loaded vibration, and even the unloaded vibration. So, guys, basically, those were different types of vibrations, which we can deal with, guys, in order to actually study the theory of vibrations. So, guys, while we got to study theory of vibrations, what we got to know, or what we got to learn to know is, guys, the sort of actions, which basically sort of actions, or rather the so-called after effects, guys, which take place, guys, on a spring, guys, that spring which basically has got that ability to resolve, guys, force of restoration, guys. Like, for example, guys, if there's a spring, guys, that spring, guys, has got a certain potential to expand it, guys, and that certain potential, guys, after that certain potential is reached, or rather, one, that so-called breaking point, or rather the most of its yield strain, guys, is reached in the spring, guys, then that spring breaks, guys, and that is known as the breakage of that spring, or rather, it is which is known as the surpassing of that so-called condition, guys, or rather of that so-called limitation, guys, or rather that so-called rate, until which that so-called spring can basically bend. And after which, guys, a restoration force of that spring, which basically helps it, which basically enables it, guys, to restore, back to its own position, guys, it does not work at all. So while we gotta study theory of vibrations, guys, what we gotta deal with is that there happen to be multiple springs, which are taken for the purpose of analytics, guys, and there happens to be a certain degree of load, guys, which is basically attached to that so-called spring, guys, and this and the ability of that restoration force, guys, of each and every spring, guys, is basically tested, and the so-called vibration, which takes place in that string, in that spring, guys, happens to be subclassified under multiple domains, guys. As I've told you, some of the major types of vibrations, such as the deterministic vibration, such as the damped vibration, even the undamped vibration, such as the torsional vibration, and such as even the longitudinal vibration, guys. So this was basically the multiple types of vibration, which we're going to deal with, in this so-called video. And, guys, the second approach, which seems to be the approach of aero-elasticity, guys, and what it basically deals with is, guys, that aero-elasticity, the name basically defines it. When we talk about aero-elasticity, what it has got to do with is, guys, that in the aerospace engineering materials, guys, when we gotta perform that rigorous testing and stuff, guys, in order to basically test, what is the degree of expansion, or rather expansivity, guys, of a so-called material, guys, what is the so-called capability of a so-called material, guys, to undergo unstress, or rather unstrain, guys. that stress, that strain, or that so-called damping, guys. When we gotta deal with all those things, especially especially from the perspective of the aerospace engineering materials, or rather the material science, which is basically used for the purpose of manufacturing of the aerospace engineering materials, or rather components, guys, maybe the aircraft fuselage and stuff. In those cases, guys, the theory of vibration, basically, plays a really important role, or rather, a really crucial role, which basically, happens to overpower the other all sciences. So, guys, the vibrational theory, is used in those all domains, guys, to study the ability of a so-called fuselage, or the ability of a certain type of metal, or a certain type of an element, guys, to basically have a force of restoration, or the force of or the ability of its expansivity, guys, or rather the coefficient of expansivity, guys. All these testings and stuff, guys, are done, guys, with due respect to the theory of vibrations, guys, or rather the vibrational theory. And guys, what the aero-elasticity means is, guys, that aero-elasticity, the name says it all, guys, that when we gotta deal with the aviation, when we gotta deal with the materials, guys, and the engineering classification, guys, which are basically not good enough, for the purpose of formulation and even fabrication of the aerospace components, or rather than an aerospace energy, guys, such as an aircraft, or rather the fuselage, or rather the body, or rather the so-called vertical and horizontal stabilizer of an aircraft, guys. That is where that so-called theorization, guys, of vibrational theory, basically comes into play. But which is why, guys, it's seriously known to be in science, guys, which is seriously evolved a lot. And guys, when it comes about those testings, guys, there is the analysis performed, guys, with the inner systems of the potential energy equations, guys. So which in fact means, guys, that potential energy is work into basically work potential into force, guys. So basically, when it breaks down in such a manner, guys, that the force comes up as the work, guys, and it comes up as force into displacement, guys. And when it's basically summation, guys, and along with the work potential, guys, that is when you find the potential energy. So, guys, the equations of the potential energy, guys, are also fundamentally used, guys, in order to study the theory of vibrations. And theory of vibration, basically plays a really important role, guys, while it even comes about development of the engineering materials, while it even comes about analytics of the stress and strain characteristics, or rather characterizations, guys, about the aircrafts. While it even comes about the relations between the stress and strain, or while we gotta obtain the diagrammatic representation, or rather the diagram, guys, of stress versus strain, and in which, guys, stress is treated to be as the axis x, and strain is treated to be as the axis y. So which is where, guys, the theory of vibrational analysis, or rather the theory of elasticity or theory of vibrations, guys, basically comes into play. So, guys, this is a topic, guys, which is absolutely essential, guys, in the domains of aeronautical engineering and even aviation. So, guys, what basically theory of vibrations helps us to do is, guys, it basically helps us to have a great discerning ability, guys, to know us, which all materials, guys, are going to be absolutely essential, guys, for the purpose of formulation of an aircraft, guys, and which are all the equipments, which are all the aerospace engineering materials, which are going to behave exactly well, guys, in those conditions, guys. Given the eventualities, or rather the scenarios of hypersonic travel and supersonic travel. So, guys, which is why theory of vibrations, or theory of damping, so rather the theory of mechanical vibrations, is absolutely essential in aerospace engineering. And as I've told you, guys, vibrations basically have to be of multitudinous types, guys. It's just the torsional, such as number 1, torsional vibration; number 2, longitudinal vibration; number 3, deterministic vibration; number 4, relative vibration; number 5, damped vibration; and number 6, undamped vibration. So, guys, that was a definitive insider, guys, about the theory of vibration, guys, which is basically essential for the study of aerospace engineering, and which is basically involved as an essential subject, guys, in the structural engineering and analysis, guys, and even for the purpose of aerospace building. So guys, if you like this video, and if you got if you really, wish to see more videos like this, guys, then please do not forget to subscribe to our channel, guys, and in order to, to basically, get those more updates, guys, please do click on the bell icon, guys, and please, to keep me motivated, guys, such that I can bring such great infographical or rather engineering updates to you, and guys, more updates soon, and thank you, and bye-bye, guys.